Hi everyone, and welcome to activity 32. Today we are going to be talking about the circumference and area of a circle, and your notes will start on page 463 in your Springboard books, and you will want to have a pencil, a calculator, and a formula sheet to keep track of your formulas. Now, on page 463, we see this figure here, and again we see that our objectives today are going to be to find the circumference of a circle and the area of a circle. Now, when we look here at a circumference and what that means, basically the circumference, I like to think of it as the perimeter of a circle. It's this distance that is around your circle. So this length here in just units, not units squared, just units. So notice they have some circular objects such as a coin, a frisbee, a clock, and a frisbee. And we have the circumference of each of these objects in comparison to its diameter. So what I want you to do is take a moment and divide the circumference by the diameter of each of these three figures, and what do you notice occurring each time? Well, what you should have noticed is that each time that we look at these, we have a ratio coming out to be about 3.14. Which you may or may not know is the approximation of the mathematical number pi. Now, pi is an irrational number, which means that we cannot put it into a fraction. So it's just always this decimal, it's irrational, and it's one of the most famous numbers in mathematics, hence why it's just stored in many calculators. Another example of an irrational number that's stored on your calculator is e. We don't really focus on that in this class as much as we focus on pi, but there are other irrational numbers out there besides pi. And again, if we notice here in this box on the connection to history, kind of talking a little bit about pi and noticing, some of its uses, some history behind it. And again, we notice that 3.14, or the approximation of pi, is crucial to the circumference of our circle. So essentially, there's kind of two different ways we look at the formula of our circumference, and that's either with respect to diameter or with respect to the radius, because we're noticing that the circumference is always going to be pi times the diameter, right? Because we discovered up there, had we divided both sides by d, it would equal pi. So kind of rearranging that equation, we get circumference is pi times diameter. Now, we also notice that 2 times the radius is also equal to the diameter. So we can make that substitution in as well to say that 2 pi r, or 2 times r times pi, is another way we look at this formula. So there's essentially two formulas, kind of depending on what you're given, either using the circumference or the diameter, okay? And again, think it is, the circumference is like the perimeter of a circle. It gets its own special name. Now, there is also a relationship between a circle, and we have also the area of some figures that we actually already know. So if we look here, we have a circle, right? And notice there's it's cut into a bunch of different shapes. And something that we can do here is we can take this and translate it so that it's actually into the cut up using these pieces. We can make it so that it is in the shape of a parallelogram, or a rectangle for that matter. And it can kind of, depending on their number of slices, is kind of how much it looks either like the parallelogram or like a rectangle, how much we cut it by. Now, remember that a rectangle and a parallelogram are going to be base times height. And essentially, that's what's happening with the area of the circle as well, since we can cut it up to make it into that shape. But the perimeter of our circle, aka the circumference of this circle, is actually coming out to be the bases, aka half the circumference is the base of our rectangle. So kind of showing this another way, if we do base times height, where the radius is the length of the height, we see this connection between these two and how they relate to each other. So that half of a base times the radius, aka pi times r, gives us that area of the circle. Okay, so that's kind of where the derivation of this pi r squared being the area of our rectangle comes in. So another formula for the day is the area of our circle, which is pi times r squared. Okay, so this is that second formula kind of, we had circumference and now we have area. Now another vocab word is introduced here, and kind of like we were looking at on there, these pictures here of, the comparison between our circle and this, transforming it into a parallelogram or rectangle. Notice there are these pieces of the circle, right? Those are called sectors, okay? And that's an important vocab word, especially in the next lesson. And I like to think of it as a piece of the pie or a piece of pizza, if you will. Okay, that would be considered your sector of your circle. It's just a piece of that. Now, how do we use these formulas, right? There's got to be a time now that we use our formulas in order to solve things. So, for instance, if we are talking about looking at the circumference of a garden that has a diameter of 20 feet, well, if we're given the diameter is 20 feet, we probably want to use that formula that pi times diameter is going to equal our circumference, right? So we're going to take 20 times pi to get our final answer. So that would be the exact answer, but if we're looking to round to the nearest tenth, we're going to type in 20, and then you want to make sure you don't just use 3.14, that you actually use the pi button on your calculator to get the best approximation possible. So 62.8. Okay. And again, circumference is just units. So in this case, feet. What if we want to find, though, the area of this? Okay, so that's going to move down. What if we want to find the area of this circular region? Well, notice the diameter, it goes across the entire circle. It's 20. For the area formula, we only have it in terms of your radius. So you have to find the radius first before you can calculate the area. So we're going to take pi times 10 squared, which is 100 pi. So we would take in our calculators 100 times pi. 314.2 if we round to the nearest 10. And now area is, of course, feet squared. Now, what if we just wanted to figure out, notice this, we have this big, circular area here, and then they're telling us we have this grassy garden in between here. And what if we wanted to figure out the area of just this region inside of here? Right, what if we wanted that? Well, it's almost like we would have to cut out the mini circle inside of the bigger circle, aka subtract the area of our smaller circle from the area of the big circle. Now, the area of the big circle is dependent on the fact that there's this 2-foot walkway all the way around. So in this case, the diameter of the little circle was 20 feet. The diameter of the big circle is 20 plus 2 plus 2 for a total of 24 units, aka the radius of our big circle is 12, right? Since the whole diameter was 24. So what we can do from here is find that area of the big circle, which is pi times 12 squared, which is 144 pi. And we know to find the area of just that blue walkway region, what we can take is the area of the bigger circle and subtract away from it the area of that smaller circle that we found up above to get that. So 144 pi, this one right here, minus the 100 pi will give us our answer. So 44 pi, or again, if we took 144 pi minus 100 pi's, we would get that approximation of 138.2. And then again, that's area, so we're talking feet squared. And that'd be our final answer then for just that walkway area. Oops. All right. Now we can from there, of course, find the areas and the circumference of other pieces, which we will work with more in class. Thanks for watching, everyone. Have a good rest of your day.